Hi, I'm Jonathan, and welcome to Defining Advanced Control Policies for SD-WAN. So in this topic, we're going to define how to define control policies, such as arbitrary VPN topologies, from simple hub and spoke to complex hierarchical policies. The lesson is going to explain how to perform traffic engineering, such as preferring one path over another, and how to do service insertion and chaining. If you're not familiar with the phrase service insertion, basically means I drop a firewall into the path or some other device, an IPS, a web proxy, etc. And service chaining is if I do multiple devices, so a firewall and an IPS and a web proxy, and I can keep doing that. So that's what service chaining means, and service insertion. Okay. Later on, we're going to be covering traffic engineering and QoS and the zone-based firewall as well. Okay. So once we're done with this topic, you should be able to describe control policy basics, how to define arbitrary VPN topologies, and by arbitrary I mean this VPN has to talk to that VPN through this VPN, etc. And we're also going to talk about describing those advanced control policies and implementing any hierarchical topology, which means stuff needs to route from this site to that site to that site. And basically, and also talking about preferred path, so if I want to prefer one link over another. And we're going to talk about how to define advanced policies for service insertion, okay? And how to implement shared services. Well, these may not make sense right now, but as we progress, we'll get into more details. So, control policies, as we discussed in the last section, are configured in vManage, and then are sent to the vSmart controllers. They're never sent to the vEdges themselves. The vSmart controllers use the policy to filter and modify that OMP routing updates to the vEdges. vSmart sorts are automatically synchronized so that each vSmart has the same view of the network. So if I say this site should not get the routes to this other site because those are restricted, the vSmart just won't allow that site to see those routes in the first place. Centralized policies influence the entire SD-WAN fabric. Therefore, central control policies are very powerful and must be well understood and tested before deployment. And down here we have a list of the devices that we can actually, the types of things we can actually do with these. So, one of the things we can do, because we run OMP over the overlay network and runs between all vEdges and vSmarts, all control information is going to be exchanged on the network over OMP. All right? So the first step, all vEdges are going to announce to the vSmarts what they can see locally, the service-side networks. All right? So site 3 here can see this network, and it's going to advertise that network into the environment. Site 2, that network into the environment, etc. Okay? An inbound policy could change this incoming flow of information. Therefore, an inbound policy could change what the vSmarts see in their routing database. So vSmart is going to get this advertisement of 2.2.2 for site 2 and advertise it to both site 3 and site 1. This is the normal behavior. If you have no policies in place, this is how we operate. We advertise your locally advertised service networks to everyone else. After the vSmart controllers receive all those OMP updates from the vEdges, the vSmart controllers store this information in their routing databases. If an incoming policy modifies those OMP updates, the vSmarts store only the modified information. This way, the routing databases hold a central view of the entire SD-WAN fabric. Okay? And here's the, so vSmart is aware of everything. Okay? Now, vSmart has gotten all these updates, now it has to distribute them. By default, of course, it's going to distribute the entire update to everyone, except the one you received. So site 2 isn't going to get 2.2.2.2 back. There's no reason for it. So it does filter out your own advertised update. We do have some split horizon here. Okay. vSmart also pushes its routing database through OMP updates to the vEdge with the out direction, i.e. to get to 2.2.2.2, use the TLOC to go to site 2, right? And this is an example of what they got. And you can see that the locals are filtered out on each of these. By this method, each vEdge is going to learn about all the other vEdges, how to reach them, the transport locators, the TLOCs, and which key to use to encrypt the data toward the vEdge, and so on. What's included here, by the way, when I say that, is all the security information for the IPsec. sorry, my handwriting's a little off. The IPsec information, the certificates, and everything else, and how we can secure that connection. Okay? The vSmart controller in the SD-WAN has a similar role as that of a route reflector, right? Remember, the vSmart gets all the routes and then reflects those routes back. If you're not familiar with BGP route reflectors, don't worry about it. But if you do, you understand how this works pretty obviously. If you don't, here is a one-sentence, 100,000 kilometer view. Basically, instead of it creating a full mesh of connections, one node is selected to reflect all the routes to the other. In this case, vSmart. An outbound policy might change the information distributed to the v-edges, and therefore the view of the network on the v-edges. For example, let's set network 2.2.2 to route via TLOC 3 on site for just site 1. So we're basically changing this from a 2 to a 3, right? And a policy can do that. So even though we still have the route for 2.2.2, right? Instead of routing it this way, we're going to route it this way. Okay? And we can use an outbound policy to enforce another topology. In the example shown, a centralized policy is applied to vSmart as follows. The policy is applied only to site 1, so announcements to other sites remain unchanged, right? The policy statement matches all announcements of site 2 and changes the TLOC to 3. As in effect, packets from site 1 to site 2 are actually sent to site 3 instead of to site 2. As an example, you can use this mechanism to do service insertion of a firewall or some other service. Okay? So let's say we have a firewall here. It's on fire. And we want to route all traffic through the firewall and then back down. The way we would do that is with one of these we do a service insertion and an outbound policy change. Okay? So how do we do this? So before we talked about how to define a simple hub and spoke topology by selecting hub and spoke up here, and then defining the hub sites, selecting the hub sites from our site list, and selecting the spoke sites, the branches, to our spokes. In this example, we're going to show a more complex control policy for creating a custom topology. So when we're doing a custom policy, we're going to choose this custom control route, this NTLOC right here, okay? And then choose two types of control policies. A route policy, which will affect the way the vRoutes are distributed. That's this guy right here. vRoutes cover the service side of the network, the local LANs behind a vEdge. And a TLOC policy affects the way that TLOC information is distributed. In the top right corner of vManage, under Custom Options, you can modify this policy. Okay. So if you need to go back or change a place in the steps, you can do it here. So if you want to go back and add a list or a topology or a traffic policy, you can move around, navigate from there. So most control policies are going to be centralized policies which affect those transport networks. Localized control policies are going to affect the service side routing at a single site on a specific vEdge router. Localized control policies are like traditional routing policies in a network. We're going to recommend you use the vManage GUI templates to define policies and not CLI templates. CLI templates are more generic, but also far more error prone. Due to the large number of routing options and parameters for BGP and OSPF, some routing options are not available through the GUI method yet. For such cases, your option is only the CLI. Okay, and as we move through this. So, in the example on this slide, VPN 1 should have a hub and spoke topology. So here's the VPN 1s. All right, so we're going to use a hub and spoke topology for VPN 1. Let me note that up here. Actually, you know what? That's right there. Okay. And VPN 2 should have full mesh because VPN 2 is being used for voice. So because voice needs to be full mesh. Because a phone over here needs to talk to a phone over here. And there's no reason to route that voice audio stream through the data center. All right, so remember this is MPLS, so the underlying topology is already any-to-any. So the control policy is going to be pushed to all involved sites and defines the following for each of those VPNs. VPN 1, spokes are going to receive only the data center prefixes, not the prefixes to the other spokes, just the hub. So VPN 1 is going to receive just the VPN 1 prefixes from the data center. Okay? VPN 2, every spoke receives information about all other sites of that VPN. And a policy is going to be defined for each VPN and applied to the sites. Okay. So here's the CLI example of the following configuration. So this first guy up here, this is actually a box, but it doesn't show it. On my screen here, this is actually a gray box. And I'm going to just draw these so that you know that they're grouped together. And there's a third section here. All right. So the first box up here shows the definition of the groups of interest as follows. So on VPN 1, the 3 branches, sites 1, 2, and 3. Right? So we call it branches, and then we list the number of sites. Okay? So that's site ID 1, 2, and 3. Remember, we're using those site IDs, so those site IDs are important. Because if I have 2 V-edges here in site 1, and I march that as site 1, 2, it groups those together, and that way the policy gets them correctly. Okay? And then we have a VPN list called VPN CRM, all right? And that's these VPNs here, VPN 1. That's not VPN 1. Okay? The second box here is going to define the actual control policy using our groups of interest that we just defined as follows. Okay? For VPN 1, CRM, we're going to reject all prefixes if they come from sites 1, 2, or 3, and accept all others. All right? So, site list, remember we defined the site list up here called branches. And we're referencing it again here. Okay? So we're matching the route for VPN 1 there. All right, so CRM. So we're matching route CRM, which is VPN 1. We're matching site list branches, which is sites 1 through 3. And our action here is to reject those prefixes. And our default action, which is always the last step, is to accept them. Okay? And all policies have sequence numbers, just like any iOS policies. So the policy is created in the sequence of ascending sequence number after this one. So we have a sequence 10 here. And we could also have a sequence 20, sequence 30, sequence 40 below it, right? Because remember, these are global policies, so they may not apply to you. So your policy might be sequence 47. And this way we can actually rechange the sequence number to put them in an order that makes sense. So the most likely traffic that's going to hit is going to match the first sequence number. And then we apply it. And we apply it to this site list. Who's going to get the policy? And the answer is these guys are. The branches, site 1, 2, and 3 that we defined up here. Okay? So once that's applied, basically we create the policy and then we activate it. Once we activate it, then the policy gets pushed out. Okay? So by default, the SD-WAN always brings up a full mesh network. Typically when networks grow really large, traffic's going to get aggregated in a region following the available bandwidth. In this case, hub sites are going to get introduced which connect to other hub sites, right? So if I have an any-to-any, this is a great idea here. The problem is if I get to a couple of hundred sites, the any-to-any network becomes unmanageable, okay? So once we introduce hub sites, we then have the hub sites are going to be connected to each other, and then each regional site will be only connected to its local hub. Okay? That way, if you're in region 2, let's say you're this V-edge over here, and you want to talk to this guy over here, your actual route path would be through your local hub to the other side. Okay? So the policy we're trying to apply here is that regional devices should not see routes to other regions' devices, but only to their local hub. And the hub sites shouldn't see the routes to other regions' devices, but instead just the other hubs. Okay? So from a hub perspective, you'd see your region and the other hubs only. You wouldn't see those end devices. All right? And let me erase that so you can see back to the diagram that was there underneath it all. All right? So here's what that ends up looking like. So we're going to create multiple hubs. All right, so this is going to be for just region 1. Okay, so we're only going to define that first hub. All right, so we're defining hub 1. our sequence 1 is going to match a TLOC for regions 2 and 3 spokes. Okay? And then our action here is going to be rejected, right? So if you're in outside of region 1, you're in region 2 or 3 here, okay? We want to reject those prefixes from hub 1, okay? Our sequence 5 is to match the routes from region 2 spokes and accept them, and set that TLOC to be going to that region 2, the region 2 hub. Okay? Then sequence 10, our site list is region 3 spokes, where action is also accept to go to the region 3 hub, and then accept all others. All right? And then on the spokes themselves, for region 1, we're going to match the TLOC for site lists 2 and 3 and reject them as well. Okay? So the spokes are going to see those region 2 and 3 spokes and reject those spokes because they don't want to see those spokes. They only want to see the hub for hub 1. All right? And then for site list for region 2 and 3, for regions 2 and 3, we're going to accept those and set those to be hub 1 to get to those routes. Okay? And then we apply the policy for the site list for hub 1 out, and then we also apply it for the region 1 spokes, the region 1 spokes out. That way region 1 spokes send all their traffic to the region 1 hub, and if they want to contact the region site list, the region 2 and 3, they actually would send their traffic directly to the hub for region 2 and region 3 respectively. Okay? So in this example, the goal is to prefer one data center over another. Okay? So you'll notice that we have 2 data centers, a main and a disaster recovery data center. All right? And we want to prefer the main data center over the disaster recovery data center. So from a routing perspective, a data center is going to be behind one or more TLOCs. The TLOC is the system IP of the corresponding vEdge, as we've mentioned, plus a color that defines the interface to use. We're omitting some details here, but you'll get the idea. To prioritize one data center over another, you have to give the corresponding TLOCs a higher preference. In the example, you must define a TLOC list. Okay? Because from a Site 3 perspective, I want to go this way first and go to this way only if that one's dead. So, how do we do this? Straightforward. We have our branches that we're defining, all right? And we're going to say, for the TLOC ID of 10.111, I want you to use get gold and MPLS, okay? And then what we're going to do is, those are the main DC TLOCs, so those are the TLOCs for these 2 sites. Okay? And we're going to say match the one for the main data center, accept it, and set its preference to 50. Remember, the default preference is 0, so 50 is better. All right? We're still going to accept the advertisement, but at the default preference, okay, as we apply it. So the goal up here is, by the way, is to define those main DC TLOCs and the branches, and then say when we receive those main DC TLOCs, set their preference. Okay? And then if we lose this connection, we'll automatically reroute to the other one because we did accept the other one. And let's talk about service insertion. Basically, the goal here is to want to add some networking service, such as a firewall, into the forwarding path of the traffic. And service chaining, as we mentioned before, it allows us to link multiple networking services together. So if you want to do a firewall and an IPS, et cetera, that would be service chaining. So if you hear that phrase, that's what they're referring to. A typical problem in many enterprise networks is that some traffic should be routed through a control point, such as a firewall, and other traffic not. In this example, VPN1 traffic should be routed through the firewall, whereas VPN2 traffic should flow directly. Note that these are separate service VPNs. So we got VPN1, which is going to be protected. VPN2 is open. Okay? So remember, we want to route VPN1, the protected VPN, that communication between these 2 VPNs, we want to route that guy through the firewall, is the goal here. So how do we do this? Well, the very first thing is we need to define the service that we're going to use here, okay? And we're basically saying service net service 1, and here's the address of it, okay? So vEdge is going to check whether that IP address of the service is reachable, and then announce the service to the rest of the VPN. Conversely, when the IP address is no longer resolvable, the service is going to be withdrawn, okay? So that first area here, we're defining the service and its address. The next one, what we're going to do is we're going to say, hey, who's our group? What's our group of interest? All right? And at this place, we're actually saying the group of interest is site ID 10. Actually, let me do it that way. All right? And this is site ID 10 down here. All right? And here's the policy. Okay? Match route for VPN 1. There's VPN 1 down here. Okay? Site ID 1. So the traffic is going from VPN 1 to site ID 1. And our action is accept, but we're setting our service to go to the net service 1 through VPN 1. And then, of course, default action accept, which is to say, accept all your other routes. And then we apply the policy as a centralized policy to the system. Okay? So an important detail about firewalls is we're going to have to see both directions of the traffic. If VPN 1 traffic from site 10 to site 1 routes through the firewall, but VPN 1 traffic from site 1 back goes direct and doesn't go through the firewall, we have asymmetric routing, and our firewall is not really going to be able to do the job it's supposed to. Okay? So with the previous slide alone, return traffic would go directly and not pass the firewall. So we're going to have to add in a policy for the return traffic to work as expected. Note, we're going to require 2 interfaces on the firewall, 1 interface for each direction, and we must define another service for the outside of the firewall connected to the second interface. So that's what these 2 guys are right here, is the 2 interfaces. Basically, like any firewall, if you're familiar with zone-based firewalls or any adaptive security appliance, we have an outside interface and an inside interface. That's how we define our security zones. Basically, the policy here is exactly the inverse of the previous slide. We have a separate net service for the other interface, all right? So it's that interface as opposed to this one. So this one of them is ingress and one of them is egress, so we're going to specify a separate service. We're going to do the same thing and verify that that service is up and running. We're going to specify our site list, which is the data center, so it's being applied to this guy right here. And then we're going to sequence 10, we're going to match the route to VPN 1, so this is only applying to VPN 1 traffic and traffic going to site ID 10. We're saying accept it and set our service, net service 2 on VPN 1. And that's referencing that. Okay? And then again, we apply it again. Realistically, though, if you looked at the apply policy, site list, DC, you'd actually have apply policy, site list DC, site list site 1, et cetera, et cetera. Okay? So notice that the site list is firewall inspected. The actual policy that you got that was being applied would be actually both of them. Okay? So in an enterprise, both the engineering group and HR require access to an internal web pages, even though the groups are in separate VPNs. So a control policy can achieve this goal, similar to an MPLS VPN setup. You import and export routes as required. Okay? So the policy detail here is going to be basically that VPN 2 and VPN 3 routes into a shared service VPN 100 and vice versa. So the service is here, and VPN 2 and 3 need to be able to talk to it. But VPN 1, we don't want him talking to anybody. Okay? So that's an overview of the policy we're about to create. So how do we implement this? Well, very first, like every other one, the very first step is going to define our groups of interest, right? So here's all extranet sites, VPN site 1, 2, 3, and 4. So 1, 2, 3, and 4. I did not cross that out. I was next to it. Okay? So the extranet clients are VPN ID 2 and 3. Okay? And our prefix list for the extranet service. And that prefix list is not on there, but we'll assume it's a loop back. Okay? So here's our policy. We're going to match the extranet clients. So this guy, references there, and we're accepting them and we're saying that they can go to VPN 100. All right? And then we're saying also on VPN 100, the service prefix up here is accepted as well. And we can export that to extranet clients. Whee. So the goal here is this, and if you can see what's happening here, is that all sites are going to get this prefix. So this prefix is going to be distributed out to everybody. All right. However, sorry. The actual policy is going to indicate in the first match statement that the extranet client VPNs are exported to VPN 100. And the second match statement in the reverse direction. So here that match is for VPN 100 and the prefix match. Those prefixes will be exported to the extranet clients. Remember the default action. Without the default action, all other prefixes would also be dropped. Okay? And then we apply the policy to the system. So control policies are going to affect the entire OMP control plane information. As you as a vEdge, as a branch site, are going to get routes based on the policies of how we allow or restrict those TLOCs and VPN routes to get to you. We can achieve all kinds of arbitrary VPN topologies by modifying those route and TLOC information in a centralized control policy. We can create a hierarchical topology, can be used in large environments for better data plane sailing. So if you have regional sites, so if I have 50 vEdges in Asia, 70 in Europe, and 200 in North America, they don't have to all route full mesh to each other. Okay? And we can also express routing preferences by using that TLOC preference. All right? So we can prefer one link over another. And we can also create services and insert those services into the path of site flows between sites. And we can also export those routes from one VPN to another in order to serve a certain service to multiple VPNs. All right. Thank you for watching, and stay tuned for the next topic.